Okay, we're going to discuss the function. This is actually lesson 11, which is the evaluation of limits of a piecewise defined function. I'm going to go through the first example here of the worksheet that was given to you in class, and it says f of x equals to x minus 1, x squared, and x minus 1 is defined for all values that are greater than or equal to 0. Actually, let me switch the paper to the side. I'm testing this out, guys, okay? So we're going to use f of x such that x minus 1 is used whenever x is greater than or equal to 0. And we have x squared whenever x is less than 0. Well, if we sketch this graph, it shouldn't be such a big issue for us now. This is the fourth or fifth week of school. We're all little Einsteins by now. So we sketch this graph, and it would look something like this at -1. And then at -1 down here, we graph the following linear equation. And we now know that this value right here obviously is the origin, so it has a value of 0. The first question they ask us is to evaluate the limit as x approaches -1 of f at x. Well, that's a pretty straightforward question. We clearly see that as x approaches -1, the y value is simply -1 squared, which gives us +1. It's a very easy limit to verify. The question lies with the second example, where they ask us to evaluate the limit as x approaches 0 of f at x. And we clearly see that there are two possibilities. From the left-hand side, as we're approaching the graph of f of x, it seems to get closer to 0. And from the right-hand side, the value of f of x seems to get close to -1. So I'm going to have to check this limit from the left and from the right. So from the left-hand side, I would write the limit as x approaches 0. And to indicate that I'm approaching 0 from the left, I'm going to write a little negative sign on the superscript. That means from the left. And as x approaches 0 from the left, the value of f of x gets closer and closer to 0. At the same time, as x approaches 0 from the right-hand side, we can actually write the limit as x approaches 0. And since we use a little negative for the left, it would make sense to use a little positive for the right. What's happening to the value of f of x as x gets closer and closer to 0 from the right? The value of f of x is getting closer to -1. We clearly see that these two values do not agree. Therefore, here's your big Lindsay Lohan moment. This limit as x approaches 0 from both sides, we say does not exist. That's example number 1. I'm going to do another example, and I want you to copy this down on your notes, or add this question onto your notes page. I'm going to give you this question. You could call this example 2. We have f of x defined as x plus 3 whenever x is less than 0. We have the square root of x whenever x is between 0 and 4. And we have e to the power of x whenever x is greater than 4. Okay? Now, in a situation like this, I would highly encourage you to graph this. So we look at the graph, x plus 3. So we go on to the 3. And it's whenever it's less than 0. So we would stop at this point with an open circle. The square root of x from 0 to 4. From 0 to 4. And we have a closed dot here. The square root of x from 0 to 4 probably looks something like this, with an open dot at the end. And if this is 4, we have to keep in mind that the square root of 4 would actually be 2. So please excuse my graph, okay? Please excuse my dear Aunt Sally. Okay, just kidding. Okay, now, e to the x, when x is greater than or equal to 4, e to the x we know looks something like this, and then 4, that would be e to the 4th, so that would be a very, very large value, and perhaps something like this. Of course, this is only a sketch. Something like this, and going up that way. Okay, now, let me ask you several questions about this graph. What would the value of f of 0 be? What would the value of f of 0 be? That's right, since x is defined from 0 to 4, including 0, you'd simply take the square root of 0, which is 0. What's the value of f at negative 4? Well, since negative 4 is less than 0, clearly it's over here, I would use this graph, and that would be, or excuse me, this line, and that would be negative 4 plus 3, and negative 4 plus 3 is negative 1. What is the value of f at 4? F at 4. Well, I come and I check at 4. Well, this is for all values of x between 0 and 4. This is for all values of x greater than 4. So is there any value defined for 4? No. Therefore, we say f of 4 is not defined. Okay? Now, regarding limits. The limit as x approaches, let's say, 3 of f of x. What's the limit as x approaches 3 of f of x? I ask myself, where is 3? 3 would be somewhere between 0 and 4. Okay, so 3 would be around here. So I clearly see I'm going to use this part. So as x approaches 3 from both sides, what is the value of this limit? That's right, the square root of 3. Perfect. Oops. Square root of 3. What would the limit as x approaches 0 be for f of x? X approaches 0 for f of x. So as x approaches 0 for f of x, what's happening in this situation? I have, from the left side, the values approaching what? 3. From the right side, the f of x values are getting very, very, very close to what? 0. So we apply the same argument, and the argument is that we have to check both sides. We have to check the limit as x approaches 0 from the left, which gives us what? That's right, 3. The values of f of x are getting close to 3. Even if it is not defined at that point, we are only checking where the f of x values get closer and closer to. So that would be 3. And since the limit as x approaches 0 from the right of f of x, that would be 0, we ask ourselves, are these two limits in agreement? The answer is no. Therefore, the limit as x approaches 0, that means from both sides, of f at x does not exist. Once again, your Lindsay Lohan moment. I want you to complete the homework questions that were assigned to you. There are 5 multiple choice and 2 free response, and I want you to complete these for tomorrow. Thank you very much. Signing off, Professor Lerma. See you tomorrow.